Hello, girls. I hope you're having a great day and staying safe at home. So, to come to the concluding part of the periodic table, today I'm going to start with the group 2 elements, that is the alkaline earth metals. Okay, so the elements that you find in the group 2 are beryllium, magnesium, calcium, strontium, barium, and radium. So these elements are known as alkaline earth metals. Why? Because the oxides are found in the earth's crust and their hydroxides are weak alkalis. Now all the elements in this group have two electrons in their outermost orbit, and if they have two electrons they can easily give away the two electrons. So what will their valency be? You know that valency will be 2. So they are placed in group 2A of the periodic table. So coming to the characteristics, I already told you, if you look at the electronic configuration of all the elements, okay, beryllium 2 so the last orbit has 2 electrons. Okay, and where are they found? Where do they occur? They are very reactive metals, less reactive than alkali metals though. So if any element is reactive, if any metal is reactive, you know they will not be found in the free state in nature. Okay, so when you look at these metals, you will see that they are grayish white in color and they are harder than the alkali metals. Okay, uh, what type of bond, chemical bond, do they show? All alkaline earth metal salts except beryllium. Exception is here, so please remember that. A ionic compound, that means they form salts by the transfer of electrons. Okay, next is action of air. They are less reactive than alkali metals. Their reactivity increases as you move down the group. So as you move down the group, the reactivity increases. Why? Because the number of shells increases, you can see, and it will be very easy for them to lose the last 2 electrons because the attraction between the nucleus in the center and the electrons, that is the atomic radius, is very long. Okay, so first is the action of water. They react with water to produce hydrogen. So you take any metal of the series, magnesium, beryllium, calcium, strontium, barium, radium, okay, any alkali metal with water, they will form an alkali, the hydroxide and hydrogen will be given out. Actions of acid, they react with dilute hydrochloric acid and dilute sulfuric acid again to produce hydrogen gases given out. The metal, any metal with hydrochloric acid, it will form the metal chloride, and with sulfuric acid it will form the metal sulfate. And of course I already told you hydrogen will be given out. Okay, and since they have 2 electrons in their outermost orbit, they form di-positive ions because they will give away the 2 electrons and it will form di-positive ions. Okay, and remember they are very strong reducing agents. Okay, when you look at the melting point and boiling point, you will see that they are low but higher than the alkali metals. Okay, now except beryllium and magnesium, all other alkaline earth metals give a certain color to the flame, that is when they are burning. Okay, these colors are very important, children. Okay, so calcium gives brick red, strontium crimson color, barium apple green, radium crimson. These colors are important, that is the color of the flame. It is also known as the flame test. They are obtained, how do you get them? By the electrolysis of their molten salts. Now the next are the halogens, or group 7A or group 17 elements. Okay, now the name halogens means sea salt former. It comes from the Greek word halo, which means sea saltogens. Okay, now the characteristics of the halogens are They have 7 electrons in their outermost orbit. So you can see 7 in all the halogens outermost orbit. They are the most reactive non-metals. For your one word answers, the most reactive non-metals, your answer will be halogens. Okay, and as one moves down the group, their reactivity decreases. Okay, if you go down the group, for example, fluorine is the most reactive and iodine is the least reactive halogen. Now there is a steady increase in melting points and boiling points as we go down the group. Fluorine is a gas, chlorine is a gas, bromine is a liquid, and iodine is a solid. Now remember, bromine is the only liquid non-metal. Now, the last element in this group, that is astatine, it is a highly radioactive and a rare element. Okay, so the intensity of the color of the element also increases from pale to dark. That is, fluorine is a pale yellow gas, chlorine is a greenish yellow gas. Children, please remember the colors are very, very important. Okay, and bromine is a reddish brown liquid and iodine is a violet solid. So you can see how the color also, from lighter colors it is becoming darker. They are all poisonous and have a similar strong pungent and unpleasant odor. They smell very bad. Okay, they all form diatomic molecules. Okay, that means F2, Cl2, I2. That means the molecule is made up of 2 atoms. And since they have 7 electrons in the outermost orbit, they can accept 1 electron to become octet. So they have valency 1 and form compounds with similar formulae. For example, hydrogen chloride HCl, hydrogen bromide HBr, hydrogen iodide HI. They produce a series of compounds with other elements. They form chlorides, bromides, and iodides, and together they are known as halides. So when we are talking about halides, what are we talking about? We are talking about chlorides, bromides, and iodides. Okay, the halogens themselves can react directly with metals to form metal halides. That means there is a direct combination reaction can take place to form the metal halide or salts. They all form negative ions carrying a single charge. That is, they can easily give away, they have 7 electrons in the outermost orbit. Okay, so they can receive 1 electron, so it becomes negatively charged. Their valency is minus 1, so they form negative ions. Fluoride F minus, chloride Cl minus, bromide Br minus, and iodide I minus. Please listen, children, before moving on to the explanation of group 0 elements, you have to submit an assignment to me on 17th July, that is Friday, at 3 p.m. And your assignment is to write about the group, all the properties and what you know about group 7A elements, and please submit it to me personally in my WhatsApp number. So moving on to group 0 or 18 group, that is the noble gases. Now when Mendeleev first made his table, group 0 was not discovered as yet. Why? Because they did not react. There was no reactivity, so it was not yet discovered. So analysis of the gases in air later led to the discovery of argon first. Helium was first detected by spectroscopy of light from the sun during an eclipse, and the other noble gases were isolated. Okay, so it was William Ramsay who isolated these gases, and he was even given the Nobel Prize. Of course, you don't have to go into detail of all these. Now, the gases, you know, the noble gases, helium, neon, argon, krypton, xenon, and radon, are known as inert gases, means they do not react at all. Why? Because the outermost orbit is filled, completely filled, either duplet, only helium is duplet, and the remaining are all octet. Okay, so In 1960s, some compounds of xenon and krypton have been made and their name was changed to noble gases. Noble means they do not mix up with any other elements or compounds. So electronic configuration, the helium with just two electrons completely filled, so duplet configuration. The remaining have 8 electrons in the outermost orbit, so outermost orbit is completely filled, octet configuration, so they do not have to give away electrons, neither receive electrons nor share electrons to form a compound. Helium has 2 in its shell and all the other members have 8 electrons, so the electronic arrangement is stable and so they are unreactive. All are colorless, tasteless, and odorless gases. They are neither inflammable, means they do not catch fire, nor do they support burning or combustion. They are monoatomic because they are made up of only one electron. Why? Because their electronic configuration is stable. Noble gases are liquefied with great difficulty. That is, it is very difficult to turn noble gases into a liquid. Now, these gases are slightly soluble in water, and from moving from helium to radon, solubility increases. That is, it becomes more and more soluble, though of course it is very, very less, very slightly soluble in water. Now, these gases emit colored light when an electrical discharge is passed through them. You have seen all these neon signs at night in front of restaurants, in front of shops, all these neon lights that you see, colored lights. It is due to the presence of these gases and electrical discharge is passed through them. The melting points and boiling points are extremely low. They have very low melting and boiling point. Helium has the lowest melting point of any element. So since helium has the lowest melting point of any element, it cannot be solidified by cooling alone. Okay, to solidify helium, pressure is also required. So all these properties point to the atoms of the noble gases being very stable. Now, the uses of noble gas depend upon their unreactive nature. They are unreactive, so whatever uses, it is because of their unreactive nature. Now, helium is used in airships and balloons because it is very light and unreactive. Argon is used to fill light bulbs because it will not react with the filament even at very high temperature. The best known use of the noble gases, I already told you, it is used in neon lights. The brightly colored advertising light works that you see, okay, I already told you, in front of restaurants and in the market, or especially in cities, all these neon lights, okay, it is used there. So what happens is an electric discharge is passed in a tube containing a little of a noble gas. So all bright colors comes out. So different gases impart different colors. Red, blue, green, you've seen all these colors. Now, the elements of group 18 are between the two most reactive groups of elements, that is group 1 and group 7A or group 17. So it is their closeness to these groups with stable electron arrangements that makes the alkali metals and the halogens so reactive. So they can easily achieve a noble gas electron structure because they can easily give away one electron or easily receive one electron. Okay, so the group 17 or 7A elements gain or share an electron, just one, while group 1A loses only one electron to achieve a noble gas electron arrangement. Okay, now moving on to the uses of the periodic table. Periodic table has been used in predicting the existence of new elements, that I had already told you before, and it is used in the past to correct the properties of elements. Study of elements and compounds have become very systematic and easy to remember. So that is the main purpose, so that the study of elements and their compounds become easier. Now, position of an element in the periodic table. If you just look at the periodic table, you will come to know, if you look at an element, you will come to know its atomic number, its electronic configuration, the number of valence electrons, and the properties. You can easily predict in a certain group or in a certain period. Okay, and nature of chemical bond, formula of compound formed, and properties of that compound can also be predicted from the periodic table. For example, elements present in group 1, 2, and 3, that is the metals, lose electrons to form positive ions, while elements of group 15, 16, and 17, which are non-metals, they can gain electron to form negative ions. So when these positive and negative ions combine, they form a compound which is electrovalent, giving and receiving, so ionic in nature. The bond is ionic in nature. So if the elements of group 14, 15, 16, and 17 combine with those of 15, 16, 17, that is non-metals with non-metals, what type of bond do they form? They form covalent bond, because they cannot give away electrons. So the only way by which they can form compounds is by sharing of electrons. Okay, so position of an element in the periodic table also tells us the valency of the element, whether the element is a metal or a non-metal. And you know, metal occupies the extreme left position at the bottom of the periodic table, while non-metals are at the extreme right of the periodic table. So children, with this we come to the end of this chapter, the periodic table. Please go through. If you do not understand, contact me in the WhatsApp group. Till then, children, stay safe. God bless you.